Okay, means the digital circuit is divided into two categories. First circuit is the combinational circuit and the second one is the sequential circuit. The difference of these two circuits I have already told in the previous some lectures. Can anyone tell me what is the difference between sequential circuit and the combinational circuit? Yes, can anyone? Please type in chat box, otherwise you can unmute yourself and talk. Yes? No one? I have already told. Suppose we see the block diagram of combinational circuit here. Suppose this is your combinational circuit. Combinational circuit. Okay. Then the combinational circuit takes input. It takes input either A, B, C, D or any input signal it gets. And combination of all the input signals, combinational circuit gives the output. As per the combination of all the input signals, it gives output. Okay. So this is output and these are the inputs. This is actual block diagram of the combinational circuit. Now we'll see what is the difference between combinational circuit and the sequential circuit. The combinational circuit, output of any combinational circuit is dependent upon the combination of input signal, combination of present input signal. Means combinational circuit works on external input of the present state only. Okay, but if you consider the sequential logic circuit, then the particular sequential logic circuit is dependent, output of the sequential logic circuit is dependent upon the present state of input also and the previous state output. Okay, and to store the previous state output, we require memory unit. Yes, the memory unit is very much important in the sequential circuit. This is only the difference between sequential circuit and the combinational circuit. Combinational circuit don't have memory unit because combinational circuit need not use the memory unit because no need to store the previous state output in the combinational circuit. Output of any combinational circuit is only dependent upon the present state or present combination of the inputs, present state input in the combinational circuit. But in case of sequential circuit, here some output of the combinational circuit means here in case of sequential circuit, it is the combinational circuit is there. In case of sequential circuit also, combinational circuit is there. Combinational circuit takes some inputs, external inputs, work on that external inputs, okay, and give some output. Then some of the outputs are going to store in the memory element. In the memory element, and then that memory element output means some of the output of the previous state of your combinational circuit is going to store in the memory element, and that particular elements are also used by the combinational circuit. Used by the combinational circuit. Means in this case, in the sequential logic circuit, the combinational circuit is dependent upon the present state input and also the previous state output. Means this combinational circuit generates the output is dependent on the previous state output and the present state input. Means this is the block diagram of sequential circuit. And previous one means except the memory unit, this is the block diagram of the combinational circuit. It takes or it considers present state input and produces some output only. Okay, it is not dependent upon the previous state output. This is the combinational circuit and the sequential circuit difference. Okay, here this is suppose positive feedback. If you want to positive feedback, if you want to store some data for further operations, then that particular data is going to store in the memory element. Not all output data is going to store in the memory element. Some of the data is going to store here, and that particular data is given here. Okay, this is called as previous state. previous state of the previous state of output. And memory unit uses clock signal as the input. This is the complete block diagram of sequential circuit. So first, draw this block diagram. Yes, all of you getting this? Yes? Okay. So just draw this block diagram. This clock signal can be represented by binary wave, rectangular binary wave. Okay. So draw it first. Yes, done. Completed. Once you are completed, please let me know. Okay. So now we will see some terminology regarding the sequential circuit. What do you mean by the present state data? What do you mean by the next state data? Here I have told already the sequential circuit is dependent upon the present state input and the previous state output. What it means? What is meaning exactly? What it mean by the present state and the next state? Just write down the definition first. The present state means what? The data stored at any given instant. The data stored by the memory element at any given instant is called as present state. Understood? Data stored by memory element at any given instant of time, then that particular data is known as present state data. Okay? And the combinational circuit works on present state input and previous state output to generate next state output. Okay, that particular means the output is generated by this combinational circuit. It is dependent upon the present state input and the previous state output. Whatever the output generated at this combinational circuit, not all the output, means complete output is not required. It is not going to store by the memory element, but some of the data is going to store by the memory element. That particular data is known as next state of the data. Understood? The difference between present state and the next state? Yes, write down for the definition of present state. Present state. Write down the data stored by the memory element. Data stored by the memory element at any given instant of time. Memory element. Yes? Am I audible? Write down the next definition, that is next state. The combinational circuit operates on the external input and the present state and the present state to produce new outputs. Means it is called as present state. Present state. Because at any instant of time, memory is going to store the data. then that particular is known as, yeah, as present state. Okay. So, okay. A repetition of next step. The combinational circuit operates on the external inputs. Combinational circuit operates on the external input and the present state to produce new outputs. To produce new outputs. Some of these new outputs are stored in the memory element. Some of these new outputs are stored in the memory element called as next stage. Called as next stage. Yes, understood what you mean by the present state and what you mean by the next state. All of you understood or any doubt is there? Yes? Present state means the data stored by the memory at any given instance of time. Then that particular data is known as present state. That particular data is used by combinational circuit in case of present state to generate the next output, next state output. Okay. Here, combinational circuit uses external input and present state data to produce next state data, and some of the next state data is going to be stored by the memory element. Okay, this is the continuous process. Every time memory unit is going to store some data. That particular data is given as input to the combinational circuit, and again that particular combinational circuit will work on the external input and the present state data, which is stored in the memory element. Okay, here memory element is present in the combinational circuit. It is absent in the combinational circuit and it is present in the sequential circuit. But what it means? Memory unit is also called as flip-flop. Memory unit is also called as flip-flop. It is very important concept in case of sequential circuit. Every time we are going to use different type of flip-flops here. That's why here, what we mean by memory element? Memory element is also called as flip-flop. Okay, then we'll see how the clock signal will work. This clock signal is the rectangular wave. Okay, then this particular signal part portion is known as low voltage, and this is called as high voltage. Okay, and when you are giving continuous voltage to your signal or to your circuit, then your circuit will produce some output at the particular instant. Okay, it is dependent upon always on the clock signal. How clock signal you are going to pass to your circuit, then it is dependent upon what output you are getting at the output of that particular sequential circuit. Means what output you are getting at the output side, it is dependent upon the clock signal. Okay, here low and high, and this is called as this age. This particular age is called as leading age. Leading age. We are going to use these terminologies in the further classes. That's why you just know what you mean by this. What is the clock signal? Clock signal is the only one input you are going to give to your sequential circuit. If your sequential circuit will work only when you are passing clock signal to your circuit. Okay, means what? This is totally dependent upon this clock signal. What clock signal you are going to pass? Either low or high. This high means what? Logic 1. High means logic 1. Low means logic 0. This particular age is known as leading age, means continuously growing age, and this particular age is known as falling age. Okay, this is known as falling age. Just draw this diagram of clock signal. Clock signal has different terminology. First is logic 0 and logic 1, which represents the signal. Okay, what signal you are going to pass to your circuit, logic 0 or logic 1, and if the edges are given to your circuit, means your circuit is suppose edge triggering or label triggering. There are two different terminologies we are going to see in the next lecture, further lectures, but it is dependent upon these terminologies of the clock signals. Either you can pass the clock signal in terms of level, or you can pass the clock signal in terms of edges. If you are passing in terms of edges, then either your signal is having leading edge or falling edge. As per that particular input, your output of the sequential circuit will change. Okay, and if you are going to pass the clock signal in the form of level, then if you are giving signal clock signal as a 0 voltage or as a 1 voltage, then and only then your circuit will work, or your circuit will give the output. Okay, understood? Just draw this diagram first. This is the clock signal diagram. It's completed. Now we'll take the structure of memory element. Structure of memory element. It is also called as flip-flop. It is also called as flip-flop. Then, not visible. Sorry. Memory element is also called as flip-flop. We'll see memory elements can be drawn by NAND gate or NOR gate. Okay, so here we will use NAND gate. One single input NAND gate we are going to use here. Okay, this is my proposed first NAND gate. Output of this one is called as Q and input will be V1. Okay, then output of first NAND gate is connected to input of second NAND gate. Input of second NAND gate, and output of the second NAND gate will be Q complement, and output of this second NAND gate is connected to input of first NAND gate. V1. Okay, this is the actual circuit of flip-flop, means the memory element. Just look at this circuit. It has cross. That's why means output of the first NAND gate is given as input to the second, and output of second is given as input to the first. That's why it is also called as cross coupled. Cross coupled circuit. Yes, understood? Or any doubt? Here, this is the circuit for memory element. It is also called as flip-flop, which is used by sequential circuit, not by combinational circuit. Flip-flop is going to store some data. It is used for storing some data. And this is the structure of this flip-flop. It has this cross component. Output of the one of the NAND gate is given as input to the second one, and output of the second one is given as input to the first one. That's why the name of the memory element or the flip-flop is also called as cross-coupled circuit. Understood? Or any doubt? Now we'll see different terminologies regarding this one. Okay, suppose operation, first operation. Assume here this circuit has two inputs. Two outputs. When consider this NAND gate. NAND gate with single input is considered as NOT gate. It will work as NOT gate. NAND gate with single input will work as NOT gate here. Okay, understood? Now we'll see first one. Suppose each Initially, assume Q is equal to 1. Assume, assume Q is equal to 1. If Q is equal to 1, then output of this Q is connected to the input of second AND gate. Okay, here V2 becomes 1. Okay, assume Q is equal to 1, then V2 becomes 1. Okay, and here if V2 is equal to 1, then output of this NAND gate, what will be the output of this NAND gate, second NAND gate? Yes, because it will work as NOT gate. Whatever, yes, whatever input you are given, output will be reverse of the input. Here, if input of this NAND gate is 1, then output becomes 0. Then this output is connected to the input of the first one, means input of this one, V1 becomes what? V1 becomes 0 now. Now, if V0 is equal to 1, then Q complement is equal to 0. Q complement is equal to 0. And if this Q complement is connected to the input of first NAND gate, that's why V1 is equal to 0. Then V1 is equal to 0. Then Q becomes 1. Q is equal to 1. Understood? Yes? Means what? When you assume Q value is equal to 0, then it continues stores value 1. Sorry. If Q is equal to 1, then it will remain 1 always. And Q complement becomes 0. Here we can say like this, Q and Q complement, output of this circuit is complementary output. Means if Q is equal to 1, then Q complement becomes 0. Q is, now we'll see next case, that is if Q is equal to 0. Consider Q is equal to 0, then how this circuit will work? If Q is equal to 0, then this 0 is connected as input here. Means right now 0, V2 becomes 0, V2 is 0, then output of this one will become 1. Now Q complement becomes 1. If Q is equal to 0, then Q complement becomes 1. If Q is equal to 1, then Q complement becomes 1, 0. In this way, we can say that output of this circuit flip-flop is complementary relationship. They are having complementary relationship. Okay, if Q is equal to 1, then Q complement becomes 0. If Q is equal to 0, then Q complement becomes 1. Understood or any doubt? Here, operations are very much important. Whenever you are considering or whenever you are drawing any circuit, then you should assume the specific value to your output, and then you have to show the output of the next complement output. Either they are using the relationship, that is complementary relationship, or not. And if such case is there, they are satisfying the relationship, then and only then that particular state is in the working condition. Okay, we can use that particular step. So draw this diagram first. This is the diagram of one big memory. Okay, memory element and flip-flop. Here, suppose B value Q can be 0, can be 1. Means what? Only one bit is going to store by such a circuit. Means whatever Q. Suppose I have stored Q is equal to 0, then Q complement becomes 1. Whenever they are executing, they are passing this clock signal to such a circuit. Every time, whenever they are passing clock signal either level wise or the age wise, then that particular signal gives Q is equal to always 0 and Q complement always 1. Means Q continues stores value 0 and Q complement continues stores value 1. That's why such a circuit is also known as one bit memory cell. This is also called as one bit memory cell. Means what? This cell can be stored only single bit. That's why it is called as one bit memory cell. Understood? Flip-flop is also called as memory element. It is also called as one bit memory cell because it is going to store only single element. It is also called as cross coupled because output of one NAND gate is given as input to the another one, and output of the second one is given as input to the first one. That's why it is called as cross coupled cell. Understood or any doubt? So Draw the circuit first. Please tell me if you have completed this. Okay. So here, as per the previous discussion, when Q is equal to 1, then Q is equal to 1, then Q complement becomes 0. This circuit has two stable states. Two stable states. Stable means what? Stable means if Q is equal to 1, it will remain 1 every time whenever you are going to pass any number of clock signal to the circuit. And if Q is equal to 0, then it will remain 0 always. Okay? Here, two stable states. First state is if Q is equal to 1 and Q complement is equal to 0. It is called as state state. It is called as state state. State state means what? When Q is equal to 1 and Q complement is equal to 0, then that particular state is known as state state. And second one, stable state is what? Q is equal to 0, then Q complement becomes 1. It is called as the reset state. Yes, understood? State state is also called as one state and the reset state is also called as zero state. Zero state. Just write down all the terminologies. We are going to use all these terminologies in the different sequential circuit. Okay. So you should know what you mean by present state, what you mean by next state, what you mean by flip flop, why it is called as one bit cell, memory cell, why, what are the two different Hello, am I audible? Okay, okay, okay. Sorry for the inconvenience. Due to network issue, I was exited. Yes. Okay. Okay. So after this, have you completed this? Have you completed this? Okay. Okay. So now we'll see the next concept that is latch concept. Again, this memory unit or flip-flop is also called as latch because the specific data is going to locking in this structure or latching in this structure. That's why that particular circuit is also known as latch. Okay, this flip-flop is also called as latch because the data is stored means locking in this system or latching in this system. That's why that circuit is also known as latch. Is also called as latch. Down this definition also, write down the cross-coupled inverter. The cross-coupled inverter is capable of is capable of locking or latching. Is capable of locking or latching the information. Hence, hence it is also called as hence it is also called as latch. It is also called as latch. Now, I already explained this. This circuit has one main disadvantage that this circuit is going to store single bit. Single bit. We can't store the desired what we want. That particular data we can't store in such a circuit. That's why this is the disadvantage of cross-coupled structure. So we can overcome this cross-coupled structure. We will see how to design the circuit values on how to overcome this drawback of cross-coupled circuit. Let's see. First one is that. Okay. Use one single input NAND gate. Use one single input NAND gate. Again, use another input and single input NAND gate. This is suppose as input of second one will be R. Then use one more NAND gate. Use one more NAND gate, but here input of this NAND gate is 2. Two number of inputs we are going to pass here. And output will be 3. Okay. Again, output of this NAND gate is given as one of the inputs of the next NAND gate, and output becomes Q component. Output becomes Q component. Then suppose here 1, 2, 3 and 4. Four number of NAND gates we are going to use here. Okay, means the drawback of the previous cross-coupled structure is overcome by this circuit. Means in the previous structure we can't add or we can't store the desired data. Whatever the data, suppose 0 is stored, then that 0 is continuously stored by that particular circuit. But this particular drawback is overcome by such a circuit. Output of this first NAND gate is given as input of the second NAND gate, and output of second NAND gate is given as input to the first NAND gate. Inputs are S and R. Single input NAND gate we are using here, and these two means NAND gate 1 and 2 are having two input NAND gates, and one of the input is output of 3 and 4 NAND gate, previous NAND gate, and the second one input will be the output of first and output of second NAND gate respectively. Okay, this is also the cross-coupled structure or cross-coupled circuit, but here we can store some data with this S and R input. Okay, understood? This is the circuit which can be overcome the drawback of the previous circuit, that is cross-coupled circuit. Understood? We'll see the operations here. We can say first operation, suppose We can take the first operation. Operation first. Assume, assume Q, S and R both are equal to 0. Assume S and R both are equal to 0. Then just consider S is equal to 0, R is equal to 0. Okay. So what will be the output of 3 and 4 gate? Can you tell me what will be the output of 3rd gate? It is worked as NOT gate. Okay. So 0 is there, then output of this NAND gate will be 1. 0 is there, output of this NAND gate will be 1. So now you should know the truth table of NAND gate. Suppose A, B and 1 is the NAND gate output. 0, 0, 0, 1, 1, 0 and 1, 1. It is reverse and gate. Okay. And gate will be 0, 0, 0 and gate will be 1 only when both inputs are. Hello, am I audible? Is this screen visible? Okay, okay. So here, if Q is equal to 0, initially I assume Q value is equal to 0. Then this 0 is given as input to this NAND gate. Okay, means 0 and 1. 0, 1, then output will be 1. Here, Q complement becomes 1 right now. And this 1, yes, I'm not audible. Yes, am I audible? Okay. And this Q complement is equal to 1, which is given as input to this 1 NAND gate. But now, this 1, at least both output will be 0. Means what? Hello, am I audible? Okay, so we will stop here. Just mark your attendance at the chat box. All of you. Roll number 1, roll number 2. Continuously, you can mark your attendance. No need to call. Yes, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 21, 22, 23, 24, 23 is not there, 27, 28, 29, 30, 31, 32, 33. Anybody is there? 31, 32 is not there. Okay, 34, 35, 36. You just mark your attendance. I will check from chat box only. I will take your attendance from chat box. So you just type. Only 33, up to 33. Okay, sorry. 44, 45, 46, 47, 48, 49. Yes. 50, 51, 52, 53, 54. Nobody is there? 51 and above. Yes.